Imagine if one of the most prescribed categories of drugs on planet Earth, to the tune of billions of dollars spent every year, were doing no good for 99% of the people taking that drug. So arguably billions of dollars wasted, while at the same time causing serious side effects in a large population, a large percentage of the people taking that drug. As you already know from the thumbnail and the description of this video, I'm talking about statins, which is the group of drugs used to lower the so-called bad cholesterol, or LDL cholesterol. And when I first saw the data published by Irish researcher Paula Byrne, I was dumbfounded, and you'll get a sense of that in a second. Incidentally, my audio in the interview is non-optimal. I sat for a while and came up with the term I was going to use, non-optimal. And it hurts me more than it hurts you, but I respect Paula Byrne's time so much I did not want to ask her to redo the interview because my audio wasn't perfect. So please excuse that, and it won't happen again. But in a moment, maybe you'll be as amazed as I was with the information on statin drugs coming from researcher Paula Byrne. This program is sponsored by VidaFair, which is my company, and yes, built on a dream. VidaFair allows independent video content creators like filmmakers, comedians, yoga instructors, telegenic chefs, investment advisors, or music video makers to set their own rental fee to rent their content to their followers, friends, and fans, who can then support that work without ever subscribing to anything. Hashtag subscription fatigue. But more on that later. Here's my interview with Paula Byrne. Paula Byrne, thanks for joining us on the podcast. We appreciate it so much.
Thank you very much for the invite. I'm delighted to share my research with you and your listeners.
I cannot tell you how fascinated is almost the wrong term. I am dumbfounded at the information you presented, and I want to just do my best to deliver some fragment of the magnitude of it. I mean, I may actually have the tendency to overstate, so you can calm me down if I'm too much of the sensationalist P.T. Barnum here. But to me, this research that you published around about a year ago, by my account, at least according to the sources I saw, stunned me. So let's get into it. And this was, by the way, not published in a tinfoil hat blog somewhere, but rather a little publication known the Journal of the American Medical Association, JAMA as it's known. And tell me if I'm getting anything wrong here. You published that statins, the statin drug family used to reduce cholesterol in people all around the world, caused a reduction in absolute risk of 0.8% for all cause of mortality. Not even 1% risk was the effectiveness, not even a reduction of 1%. It was less than 1% reduction of mortality risk from taking statins. Is that a fair summary?
Yes, it is. So what we were talking about was the absolute risk reduction from statins. We did what's called a systematic review and meta-analysis of 21 statin trials. So they would be the big trials that have been used to inform practice and guidelines over the years. And what we did was bring them all together, analyze them together, and then come up with a summary result. So yes, we found a 0.8% risk reduction in all-cause mortality, a 1.3% reduction in heart attacks, otherwise known as myocardial infarctions, and a 0.4% reduction in stroke to those who were taking statins compared with those who were not. But what I might, if I could take a little segue, Bob, just to describe, because this might sound a bit strange to people when they're used to hearing bigger stats in terms of the effectiveness of statins. So what we described just there is called the absolute risk reduction. And what we're used to hearing is called the relative risk reduction. So if I could just simply explain what that was. So supposing I had a drug trial on some fantasy drug, and we're looking at whether or not it reduces heart attacks. And supposing I told you I divided the people in the trial into a group that took a dummy pill or a placebo and those who took the actual drug. And then I tell you, in the placebo group, in the dummy pill group, there were 10 heart attacks. In the drug group, there were 5 heart attacks over the course of the trial. So the difference between 10 and 5 is a 50% reduction. And that's what you'll hear reported. That's the relative risk reduction. But what I didn't tell you is that maybe there's 100 people in each arm of the trial. So your chance of having the heart attack is low anyway. 90 in the placebo group compared with 95 in the drug group didn't have a heart attack. So now I know that my risk reduction from 10 to 5 is actually a 5% risk reduction in the context of there being 100 people in each arm. So we very often see the benefits of all drugs, not just statins, presented as relative risk reductions, which make them seem bigger and better. And that's what patients are used to hearing, and often what doctors are used to hearing, and what they would base their decision making on.
And just to extend your analogy a bit, if there were 1,000 people instead of 100, and the risk went from 10 heart attacks to 5 out of 1,000, they would still present the identical relative risk reduction, right? It would still be 10 versus 5. And it would still say 50% in reduction of although now we're talking about a population of 1,000. Or if a population were 10,000 or 100,000, the 10 to 5 would still be presented with the identical relative risk reduction.
That's right. Yeah. And it's a big problem for decision making in healthcare, for patients and for doctors. Yeah. And the thing with statins is that they are an extremely frequently prescribed drug. So at the beginning of my journey into looking at statins, I did an analysis of older people in Ireland. And it was a group of over 50s that kind of represent community dwelling people in Ireland. They would be, we'd be pretty sure this is what is happening in the community. So we found that about 30% of the over 50s we looked at were taking statins. Now that ties in with other studies, particularly around Europe. I would imagine it's the same in the US. We would have about that kind of rate of statin use. So they're very frequently prescribed drugs. And that, of course, has implications for the payer, whoever is paying for that, whether it is the state or insurance bodies or whatever like that. So it is important from 2 perspectives. One, from the point of view of the person who is taking the drug, and is it worth, if I knew that the absolute risk reduction was that small, would I choose to take the drug? But secondly, in terms of low value care and potential waste in the healthcare system, I think it's an extremely important thing to consider. So does the state know, or the payer know, that the absolute risk reductions are that small?
And we'll get into later the issue of complications or side effects that statin drugs can cause. And I noted something that amused and also kind of surprised me in the sense that oftentimes the side effects are presented in an absolute. I'm actually finding sources where when they're citing the bad part of statins, they're saying, oh, well, here's the absolute risk of this bad thing happening. It's 1 in 10,000 people or 1 in 1,000 people. And yet when they're explaining the benefits of statins, they're not using the absolute numbers. But anyway, let me dive in a little more on what you said a second ago about how many people take statins around the world. And I think a number that was from your piece I saw said that from 1987 to 2020, I guess statins became commonly prescribed in 1987. $1 trillion has been spent on this category of drugs. I mean, a stunning amount of money. And the fascinating thing that you explained to me was that there has not been a consistent percentage of people who are considered candidates for statins over time, right? That candidate pool has changed quite a bit.
Yes, that's true. And that is true for a lot of drugs. And this comes from clinical guidelines, which obviously guide doctors in their practice. So clinical guidelines change over time with evolving evidence. We would expect that to happen. However, there was a very good review done by, I think it was Paul Glazou and colleagues in Australia, where they looked at a number of clinical guidelines in a whole lot of different areas of healthcare, and found that in general, over time, clinical guidelines expand potential eligibility for whatever the drug is. So we did a study where we looked at, European clinical guidelines for cardiovascular disease over time. So the first guideline we looked at was written in 1987, and the last one was written in 2016. Now, there have been newer ones, but we haven't kind of looked at them yet. So we looked at this same group of over 50s in Ireland. Now, nothing had changed in the group of people. What had changed, we just modeled the effect of those guideline recommendations on that group of people and how many people would be eligible for statins if we took those different clinical guidelines over time. So in 1987, there would have been 8% of that group of over 50s eligible for statins. By 2016, now nothing has changed in the group, 61% of that group would have been eligible for statins. So that kind of blew our minds. You know, we knew that there was an expansion of eligibility, but we did not realize it was that big. So obviously,
what's the limit on that? Clearly, the drug companies make more money the lower the bar they set. Well, you know what? Pretty soon, will it just be our indication of whether statins should be prescribed is that you're breathing? Like that's like the future. Like just hey, we get millions of dollars and more money just by lowering the, here's your LDL cholesterol number. Oh, let's make it a lower number and a lower number and a lower number. And yeah. I don't know what checks that.
I suppose what checks that is good evidence. And that's what we're trying to do, and hoping that guideline developers will use evolving evidence, So there has to be, I feel very strongly about this division between research, clinical guideline development, payers and the pharmaceutical companies. We really need to keep almost an adversarial relationship between particularly guideline developers and industry. I would feel that that's really important.
They certainly have an incentive to lower it always and make it ever lower and lower, and meaning a widening and widening number of people that get their drugs. So let's back up a bit, though. The essence of why people take statins is to lower cholesterol, and that's because researchers found that high cholesterol is correlated with heart disease and heart attack and stroke and death. High cholesterol is correlated with bad things like death. Mm-hmm. And then they found we have these drugs called statins, which reduce cholesterol, particularly LDL, so-called bad cholesterol. And so it's the inference being that if high cholesterol causes heart attacks and death, then lower cholesterol from statins would therefore reduce death. I mean, that seems to be most people could accept that logic, I think, right?
Mm-hmm. Mm-hmm. Yes, and again, that is the fundamental of a lot of the clinical guidelines in cardiovascular disease. So the second part of our JAMA internal medicine paper was looking at just that. So as you said, you would assume that if LDL cholesterol is associated with those bad outcomes, that the greater the reduction, the lower your LDL cholesterol, then the lower the frequency of those outcomes. And that's called a linear relationship. You can imagine a line, low LDL, bad outcomes, and the higher and higher the LDL gets, the greater your outcomes. However, we failed to find a linear relationship between LDL cholesterol lowering and these three outcomes of all-cause death, heart attack, and stroke. Now, other systematic reviews that have looked at this and that influence clinical guidelines did find a linear relationship. And the reason we think that we were different was because of what we chose to measure. So what were the outcomes of interest in our paper? And you'll find in a lot of cardiovascular research, we have what's called composite outcomes. So say a study is going to look at, well, what's the effect on LDL lowering on something called major cardiovascular events. Now that could, if I always envisage it as a bucket that you could put in a whole lot of different outcomes. So it includes heart attacks, strokes, maybe angina, maybe revascularizations or hospital admissions or whatever it is. And it's all put together and called major cardiovascular events or major vascular events or something like that. Now, the problem with measuring an outcome like that is you don't know what's in the bucket. Is it made up of a huge amount of less important, arguably, outcomes like angina and revascularizations, or is it made up of serious hard outcomes like heart attack and death? So that was the reason when we did our study, we said we're only going to look at these hard outcomes. It's pretty clear when somebody dies of any cause. It's relatively clear when they've had a heart attack. Now, arguably, that has changed its definition over time, and it's clear when somebody has a stroke. So we decided we're only going to look at those hard outcomes. So we think that that's why we failed to find this linear relationship.
And what you call linear, it could be a curve. I think what you're really describing is a causal relationship, right? A direct through cause from the cholesterol's high, therefore the incidents happen. And you're saying that these other researchers did find a connection between the statins, I guess, beginning
the lowering,
of statins,
or the LDL lowering, yeah.
Just the LDL lowering, okay.
Yeah.
So they found a connection between the LDL lowering and incidents, but they're including a lot more minor incidents in what you described the bucket of what they're measuring. They're measuring a lot more minor incidents, and you said if we just measure things that are the most serious incidents, then we fail to find this causal relationship between lowering LDL and death, heart attack, etc. Did I rephrase your words properly?
That's correct. Just to again put, you asked me to pull you back a little bit.
Please.
So we don't know often what's in those composite outcomes. So we don't know if it's made up of, very often they don't report all the parts of the composite outcome. So it's usually the case that we don't know what's in the bucket rather than that we know that it's all less important outcomes. Okay. It's just that, and fair again, enough. That kind of highlights the idea of transparency in research, that you report as much as you possibly can so somebody else can go back and have a look through and see, is it correct?
Right. And there could also be a distinction lurking here in a difference between just having high genetic LDL, high bad cholesterol. It could be that actually does lead to heart attack, but the lowering of the number does not necessarily mean lower heart attacks, right? It could be that, in other words, when people talk about correlation versus causality, you'll hear people talk about that a lot. Mm-hmm. They'll say ice cream eating is correlated to shark attacks. The months with more ice cream consumption are the same months that have more shark attacks. But it's not because eating ice cream causes a shark to attack you. It's because warm summer months are when you eat ice cream, and warm summer months are also when you go swimming in the ocean more often. And so the sharks can see you around. And so there's this other factor, which is the temperature being warm, that's driving both of these measured things. And they are correlated, but they're not causal. They're not causing each other. There's some other factor, meaning warm temperature, is causing both of the things. So, for example, in this scenario, there could be you could find a correlation between cholesterol and death, and maybe some other thing is causing both. Therefore, if you lower the cholesterol, that could possibly mean you're not lowering the death.
Yeah. So this is the eternal quest for researchers, causation and correlation, and it's extremely difficult to figure out. But I would say that the systematic review that we did included 21 randomized controlled trials. Now, randomized controlled trials are the best way of trying to get rid of all those other factors, the confounding factors, as we call them. So in fairness, these were randomized controlled trial, and we did assess them for risk of bias. We do all these different tests for bias and for certainty and quality of evidence. So they were randomized controlled trials, but you can never be 100% sure that you're getting rid of all confounding factors. So what you try to do in a randomized trial is you get two groups of people that are very, very similar. Ideally, you want them identical, except for the drug or intervention that you're giving one group. And there certainly are biases. For example, there would have been a lot more what was called publication bias in the past. So that would mean that trials that had positive outcomes were more likely to be published than those that did not. So if a drug company undertakes a trial and it's not going the way they wanted it, they would not have published the trial. Now we're definitely better at that nowadays. A lot of trialists in a lot of countries now, you have to register your trial before you start it. So we know that there's a trial ongoing, and therefore if the trial results are missing in a couple of years, you can go back and say, well, what happened in that trial? And that was not as strong when the original statin trials were coming out. So there could be a risk of publication bias. It's hard to know. But there are always biases. We're always trying to figure out what the risk of bias in a particular trial is. And
yeah, but let me ask you about a kind of bias you don't have, which is this is not your study. You're not manipulating. You didn't say, oh, I want some sensational paper in the Journal of American Medical Association. You are looking at other people's data, which largely, or maybe all of it, was drug company funded. Is that right?
Yeah, they would largely have been drug company funded trials, I think. Yeah.
Right, so they have every incentive to show there is efficacy to statins, and yet you're still finding this in their data.
Yeah. So we did find benefits to statins. It's just that they were quite small in terms of absolute risk.
Yes, and also there's population differences, right? If someone's already had a heart attack, then the value of statins is higher. Isn't that right?
I suppose you still have you have to consider your own. You're now getting into what is your own risk of, risk, and we can calculate that using these cardiovascular risk calculators. What is your risk of developing whatever it is in the future? So, there's a big difference between, say, now I'll use all the cliches here, but say a middle-aged overweight man who smokes and doesn't take exercise, who might have a high risk of cardiovascular disease, compared with a younger woman who's fit, who doesn't smoke. She's going to have a much lower overall risk anyway. So then if you reduce that risk by whatever, X%, there's a difference between the benefits to those two people. Yeah.
Sure. All kinds of population differences, including, those you named. Yeah. Let me just read you from the Mayo Clinic website here in the United States. Quote, statins are effective at lowering cholesterol and protecting against a heart attack and stroke.
Mm-hmm.
That's message to the public. Now, you would say, well, are effective at protecting against a heart attack? You'd be like, yeah, if you consider less than 1% change, like a fraction of 1% lowered risk, if you define that as effective, then I guess so. But I guess I wanted to ask you, when you see stuff like this, does it strike you as bad information?
Does it strike me as what?
Bad information.
Bad information. If you take it as exactly what it said, it's correct. So it does. Statins do reduce.
Misleading is maybe I should have used the word misleading. You say are effective at. Just throw it like parentheses, although the efficacy is less than 1%.
Yeah. So I would argue that should be put in there, and that the absolute risk reduction should be presented to doctors and to patients. Absolutely. Statins are very good at lowering LDL cholesterol. There's no doubt about that. And that's why when we look at, the idea of using diet or lifestyle, it's very difficult to lower your LDL cholesterol, and statins will do them quite quickly and effectively. So that has been the narrative, and I suppose that's what we're interested. We're moving on now to look at not just statins. Our current research project is looking at all the cholesterol lowering drugs, including newer ones, and we're kind of repeating the analysis. So we're actually targeting LDL now, rather than the statins just themselves. So anything that lowers LDL cholesterol, we're going to look at and see, what the effect of that is.
Yeah. I'm stunned by this stuff, Paula. I got to tell you, I think this is a mic drop. I don't know why this isn't being covered by every media group. in all around the world all the time. We're talking about billions and billions of dollars spent on drugs that could be, for large millions of people, ineffective completely, and not just ineffective, but with side effects. And I thought the side effect aspect would originally be a small part of this interview till I started looking into it. WebMD listing side effects of statins says drowsiness, dizziness, nausea, vomiting, diarrhea, hair loss, pins and needles sensations, liver inflammation, pancreas inflammation, acne, erectile dysfunction. Statins, I'm reading from the WebMD.com. Statins also carry warnings of memory loss, mental confusion, neuropathy, high blood sugar, and type 2 diabetes are possible side effects. And then it gets to a headline that says, now here are the serious side. Those were the non-serious side effects, Paul. It says here are the serious ones. Myositis, which is inflammation of the muscles. Rhabdomyolysis, extreme muscle inflammation and damage, which could end up damaging the kidneys and could eventually cause kidney failure and death, it says. Although, and then here's the funny part I alluded to earlier. It says, although this happens in less than 1 in 10,000 people. Mm-hmm. So when it comes to that particular side effect, a very low risk, that's expressed in absolute terms.
Thanks for watching part 1 of my interview with Paula Byrne. If you came this far, please click like and subscribe. It helps us with the algorithm. But also consider renting part 2 of the interview, in which I will let her answer that question I just posed about the statin side effects, as well as differences between statins. I pull up a list of 7 different kinds of statin drugs. A lot of people are familiar with Zocor and Lipitor, and the generic versions of both of those, which are 2 of the top 10 most prescribed drugs in the world. As well as I'm going to ask her who else has published on this same subject matter, and we'll discuss that. The link for part 2 will be in the description of this video. It only costs $1.99, and that's a la carte. You save 50% if you buy the VidaFair tokens called grains. And so then that's a way of giving a volume discount without ever asking people to subscribe. Volume discount by buying a large batch of our tokens called grains. But even if you don't do that, it's only $1.99, purely a la carte. Please consider renting part 2, and we'll see you next time.